Okay, so after those first two examples that work nicely, we're gonna look at some that don't work quite as nicely. So the next one that we're gonna see is r of x equals, what do I got here? 4x over x plus 1 squared. Okie dokie. So on this guy, same thing goes, vertical, horizontal intercepts, okay? Same thing. So for our vertical asymptote, we're gonna take that bottom and set it equal to 0. We don't even need the squared though. The squared isn't gonna affect us. The part that would make, or the number that would make the bottom equal to 0 is a -1, right? Okay, so again, we can draw a nice graph here. And we already know that our graph is going to have an asymptote at -1, vertical asymptote. And then we're going to go with our horizontal asymptote. Now on this one, you need to be just a teeny bit more careful because of the way the bottom is written. So when we look at our degree on the top, the degree on the top is 1, but what's the degree on the bottom? So the degree down here, right now it might look like just 1, but if we FOIL this out, it's actually going to be x squared blah 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 blah. So the degree on the bottom is actually 2, so they're not the same. The top is smaller than the bottom, and that's when we get y equals 0 as our horizontal asymptote. So again, another one where we're right here on the line. So we will give it a label. Okay. All right, and now our intercepts. So our y-intercept here, we want r of 0. So if we put 0 up top, we're just gonna have 0, and then we're gonna have 0 plus 1 squared. So 0 over 1 is just 0. Okay, now we do tend to have a little bit of an issue going on here. Okay, our y-intercept is 0. We got another one that's on the horizontal asymptote. Okay, so we have another issue going on here. Okay, we'll deal with it in a minute. Let's find our x-intercepts first. So remember, we don't need the bottom, do we? We just need to take 4x and set it equal to 0. So x equals 0 as well. But look it, if it's an x-intercept, if it's a y-intercept, it's also an x-intercept. So unfortunately on this one, we got very little information. So this one is going to require some test points. Definitely going to require some test points. So first, let's figure out what's going on this side. So we know that there's going to be some graph that's hugging, but the question is, does it come down here or is it up top? So again, pick a test point, maybe like -2, and we're going to plug in. So if we want r of -2, we go 4 times -2 over -2 plus 1 squared. So this one is going to be -8 over -2 plus 1 is -1 squared. It's still 1. It's still positive, isn't it? So this ends up being -8, which actually means, maybe somewhere down here. Now, does that tell us, is the arc going to be up here? No, it can't be because the point is down here. So the arc is going to look like that. We just do the best we can. It doesn't need to be perfect. Now, over here we have this point, but nothing else. And these are fractions, so I think I'm going to go this way and just stick in 1. Okay, so our test point over here, let's go r of 1. If we go 4 times 1 over 1 plus 1 squared, we'll have actually 4 over 1 plus 1 is 2 squared 4. So that's a nice positive 1. So we know, like, you know, up here. Now again, believe it or not, we have everything we need, okay? So from this point, it's got to go up to this point, okay? For sure. But now, because of the way the graph is headed towards here, this guy is going to come down and hug there. Now here's where this gets weird. We crossed the asymptote, but I can tell you that because of the definition of an asymptote, this thing doesn't continue to grow. It has to eventually come down and hug this asymptote. So it's going to eventually come back down and reach towards the asymptote. So this is one that has a little bit of a bump in it. Now, sometimes the bump is a little bit steeper, sometimes it's a little bit shallower, but it crossed, which it can do in the middle, bumps up a little bit, but then it's being drawn towards that asymptote, so it has to go back down. It doesn't have a choice. Okay, so another kind of weirder looking one. Okay. And now we're gonna see the weirdest one. And this one is the oblique asymptote. And an oblique asymptote is one that is not a vertical or horizontal line. So this could be a diagonal line. An asymptote could actually be a circle, and the graph might fit inside the circle, like it might be like a square or something inside a circle. But an oblique asymptote just means it's not normal. We have to figure out what it is, but it's not normal. So we need to first see an example of that so we can see how we're going to graph this. So let's see. The guy that I have here is r of x is 2x squared plus 3x minus 5 all over x plus 2. And we're not worried about the vertical asymptote right now. We're not even worried about graphing. We're just looking at this oblique asymptote. And remember that that oblique asymptote pops up because the the degree in the numerator is higher than the degree in the denominator. Okay. So it's kind of like an improper fraction. So that's what tells us it's oblique. Now, in order to find this, we're going to use something that we learned in the last chapter. So we're going to use synthetic division. So luckily, the thing that we're going to use was not too bad. Okay? But we're going to do a synthetic division problem here because basically it is a division problem, isn't it? So we're going to draw our little box, put our numbers in our box, 2, 3, -5. Now remember, when it's in this form, we're putting -2 on the outside, flipping the sign. Okay, so we bring down the 2. That gives us -4, which gives us -1, which gives us 2, which gives us -3. Now, in the last chapter, we were focused on that remainder, weren't we? We didn't work with this too much. We did some, but we were focused on that remainder. In this chapter, when we're doing rationals, we don't care about the remainder. This is the oblique asymptote. Okay, that's what we're looking at. We're looking at that quotient. And what we need to do is rebuild it. So if this was a squared, it means this is just going to be a single x. So it's 2x minus 1. So our oblique asymptote is actually just a diagonal line. It's not a horizontal, it's just a diagonal. We can graph that, we can do that, okay? But that's how the process goes. We do the synthetic division, we cancel out the remainder, and we focus on the quotient. So, with that being done, I guess we can go ahead and graph this. Now normally we start with the vertical, but we've got our oblique, so we'll graph it in here. So y-intercept is going to be -1, and then our slope is 2, so we're going to go up 2 and over 1, so we'll go there. Now here's the only thing you have to remember, it's an asymptote, so as you draw it in, you're drawing it in dashed. Oblique asymptote in there dashed. So this just means instead of this graph being more vertical like our last couple, it's just off kilter a little bit. We can do that. Now we got our oblique. Let's go back to the original and just find our vertical asymptote. So now we're just looking at this guy, and that's going to be x equals -2. So we will come over here to -2. So instead of our asymptotes cutting us into like rectangle shapes, we've got kind of weird triangular shapes going on. Okay. All right, we need our x and y intercepts. So let's go with our y-intercept. Let's see if I can fit it right here. Y-intercept. So r of 0, remember everything falls away and we just have -5 over 2, okay? -5/2, which is -2.5. So our y-intercept is negative, so it's going down, 2.5. So we'll say about there. Okay. And then put our x-intercepts over here. Now for our x-intercepts, who gets set equal to 0? The whole thing and the denominator cancels out. So we're actually just looking at 2x squared plus 3x minus 5 equals 0. Okay. I hate factoring these guys when there's a number out in front, but at least it's just a 2. So on this one, we know there's going to be a 1 and a 5 at the end. Now, if we put a 2 and a 1 like that, then we're going to get 10 and 1. That's not going to get us a 3, is it? But if we do 2x here and the x here, now in the middle we're going to have 5 and 2. And if we want a 3, we could go plus 5 minus the 2. So a little bit of factoring there. So x is going to equal 1. And over here, x is going to equal -5/2 again. So -5/2 is a pattern going on here. Alrighty. So now these are x's. So there's going to be 1, which is right there. And -5/2 or -2.5 is going to put us there-ish. Now, believe it or not, we've got everything we need. We don't even need any test points here. Let me show you why. Let's look on this side of this vertical asymptote. The graph could either be in this big region here or in this littler region down here. How do I know that it's in this region? Because of that point. Now, even though the asymptote is a little bit ugly, we're going to do the same thing. It has to hug that asymptote. It's just going to look a little bit weirder because it's not making that sharp turn. So it's more like this long sweeping turn. Now, on this side of the graph, we've got this region and we've got this whole region. There's 2 points right here that have to connect. So is it gonna be up here? It's gotta be, if we're on this side, it's gotta be down here. So again, this guy is going to come like this, get close there, and then this is gonna just kind of slowly hug up. It almost looks like it's sort of becoming a straight line. So instead of being much more archy like that, we're definitely like pulling it, and so we kind of pulled it diagonal and it really stretches out a little bit. But that's what the oblique asymptote does to the graph. Okay, so that's 4.1 and 4.2. Again, done together because why not? If you're gonna do it, you might as well do the whole thing. Now, I'm leaving you here just so the videos aren't super duper long, but you guys let me know in the discussion. Let me know if you want to see another example, if you want to do another want me to do another example like out of the book or something. I'm happy to do another little short video to upload if you guys want to see it, but I'll leave that to you. All you have to do is ask. I'm happy to do it, okay? Alrighty, there we go. Okay, see you next time.